Welcome back, everybody. This is going to be our Algebra 2 linear functions, lesson 1, which is a direct variation homework review part 2. And again, in this case, if you haven't had a chance, please watch part 1 for the notes on direct variation, about the idea of a constant variation. And so we are now doing some word problems on this situation, but again, the keywords are trying to figure out how to set up our problems here. So we'll start with question number 5. For his workout, the increase in Jacob's body rate is directly proportional. So the increase in Jacob's body rate is directly proportional to the amount of time spent working out. So in this case, our comparisons will be increase in heart rate over time. That's what we're comparing. And so if his heartbeat is increased by 8 beats per minute after a 20-minute workout, so that's what we have, the 8 going with the increase in heart rate, and the time is 20 minutes. How much will his heartbeat have increased after 30 minutes of workout? So that's n over 30. So again, a lot of times, I believe the question a lot of students have is going to be, how do I solve my problems? And the key thing in this case is going to be reading carefully. And if we see direct proportional, we create a proportion here. And so here, again, I'm going to simplify the 8 over 20, but this time, I could divide both by 4, but I'm going to divide both by 2, and you'll see why in a minute, though. So here I'll have 4 over 10 equals n over 30. And you say, well, why is that the case? Well, I can easily see that 10 goes into 33 times. So I'm going to multiply 4 by 3. So in this case, the increase n is equal to 12. And we'll summarize this in our following statement, saying that the increase, okay, so Jacob's increase in heart rate will be 12 beats per minute after a 30-minute workout. Okay, now a lot of times, oops, Jacob, not Jacobs, sorry, typing needs to work. So again, a lot of times we're not just going to just find numerical value, we have to interpret what the value means. So this n of 12 really means an increase of 12 beats per minute, okay? So after a 30-minute workout. Okay, so after working out for 30 minutes. Let's just say after working out for 30 minutes. Okay, question number 6. When a photographer is enlarged or shrunken, its width and length, when photograph, it's enlarged, shrunken, its width and length stay proportional to the original width and length. Rojas is enlarging a picture whose original width was 3 inches and whose original length is 5 inches. If the new length is to be 8 inches, what is the exact value of the new width in inches? So we are going now comparing. We see in this case we're comparing our width and length. Width and length stay proportional. So we have our width and our length. So the original picture is going to have a width of 3 inches, and the original length is 5 inches. If we're enlarging it, so the new length is 8 inches, so the end length is denominator, and we want to figure out the numerator, n in this case. Well, the 3 and the 5 don't simplify out, so we're going to definitely cross multiply here. So we have 3 times 8. And then we have is equal to 5 times n. Or we get 24 is equal to 5n. All right, so now we want to figure out what the number of inches the new width will be, okay? So we divide both sides by 5. So 5 goes to 24. Let's take a look here. I think definitely 4 times. Let's get 20. With the remainder of 4, so in this case, 5 goes to 48. So it looks like in this case 4.8 inches. So we would say the new width of the photograph whose length is 8 inches will be 4.8 inches. Okay, so the width of the photograph will be 4.8 inches. So again, we'll get a proper interpretation of what the number represents. So we're not just solving, we want to be able to give a description of what our number is going to give. So, question number 7. For a set amount of time, the distance Kirk can run is directly related to the average speed. So again, we see words that the distance Kirk can run is directly related to or directly varies to his average speed. So we're going to set this up, in this case, as distance over speed. Now we know where everything goes in our setup. So our distance over speed, that Kirk can run 3 miles while running at 6 miles an hour. How far can he run? So we're looking for a distance here. In the same amount of time, if his speed increases to 10 miles an hour. All right, and again, we want to make sure, again, what are we comparing? We're comparing his distance as well as his speed. Actually, in this case, interesting enough that the distance and speed is going to be giving us our time, because rate times time equals distance, so distance over rate is equal to time. And so we have here 3 over 6 simplified to 1 over 2. Make it easier for ourselves. And we see 2 goes to 10 5 times. Therefore, we get d is equal to 5. And our summary in this case, because we'll summarize this here. So we want to say that Kirk will cover or run a distance of 5 miles when in the same amount of time. Okay, at the same amount of time when his speed is 10 miles per hour. Okay. All right, because that's what they're asking for. How far can he run if he's traveling to the same amount of time but decreases his speed to 10 miles an hour? Okay. All right, and now question number 8. 2 variables are proportional if they can be written as y equals k times x, where k is some constant. This leads to the fact that when x equals 0, then y equals 0 as well. Is the temperature measured in Celsius proportional to the temperature measured in Fahrenheit? Okay, well, it would make sense that that when x equals 0, y equals 0, if they're direct proportional, because if y 0 times any value is equal to 0. We just can't write it in terms of with the constant variation wouldn't even matter in this case. So is the temperature of Celsius proportional to temperature in Fahrenheit? And we would say in this case, well, we know that based upon this idea, okay, that 0 degrees Celsius basically occurs the same temperature as 32 degrees Fahrenheit. Okay? And we also know that 100 degrees Celsius equals 212 degrees Fahrenheit. Right? Well, here's the thing. If we do Celsius over Fahrenheit, is 0 over 332 actually equal to 100 over 212? And the answer is no, not equal. Well, how do I know? Well, 0 times 212 is not equal to 100 times 32. Definitely not going to be direct proportional. Okay, so there is no direct variation. So the answer is going to be no. No. Celsius. Oh man, Celsius and Fahrenheit. I gotta spell that here. Fahrenheit. Okay. Oh, I forgot the H here. Spelling is terrible. Sorry about that, ladies and gentlemen. Oops, not capital H. Okay. Celsius and Fahrenheit temperatures are not not proportional to each other. Okay, so we see in this case that they are, in this case, they do not give us the ratio. Well, let's put it this way: the ratio of the temperatures are not equal to each other. Okay, remember for direct variation, the ratios temperature have to be the same. So Celsius over Fahrenheit, would have to be equal to no matter what. In this case, see 0.32 is not the same as 100 over 212. Okay, so we'll encounter situations where it does work out. All right, ladies and gentlemen, this is the last question for homework. I hope it was helpful to you guys, and just hopefully keep following us for the rest of our lesson reviews for the Algebra 2 topics. We look forward to presenting lesson 2 for you guys. Now, if you can, please give this video a like. And if you have any questions or comments or any feedback, whether you thought it was okay, whether you have corrections, which I definitely sometimes need to be corrected and all that, please leave in the comments below. I look forward to hearing from you guys. So thanks so much for watching. All right, subscribe to the channel if you have not done so already. And yeah, thanks for coming and learning math with us. Now, again, not too late to go remote, ladies and gentlemen, at this time. All right, I know the hope of all my students are going remote, and in this case, they can just watch the videos, and also probably me chat in the classroom if you guys have any questions. So I'm looking forward for the classes to start, and in any case, hope you guys are all safe. All right, and hope you guys are taking care of yourselves and all. All right, see you guys in the next video.